Good morning, students. Let us continue with the module 1, that is the second half part of the module 1, transducers and sensors. In the last sessions, we saw discussion about the transducers, and today we will start with the sensors, majorly definition of the sensor and various types of the sensors. Along with that, we will discuss the light sensors also. So this is a typical example taken of a car body is having the so many sensors. So all these are automotive sensors since they sense the function or particular activity in an automobile. So car is taken as an example here. You can see headlight range sensor, chassis level sensor, motor position sensor. So various sensors are being kept in the car. In the back side, you can see wheel speed sensor, mirror sensor, accelerator pedal angle sensor, transmission sensor, so to control the steering sensor. So you can come to know that where the sensors are being used. So we'll start with the sensors with the definition. Sensor, it is an element which produces a signal relating to the quantity being measured. Ultimately, why we are sensing? Because we have to measure the input, which is a measurand. So it is a sensor, it is an element, it produces the signal, that is output, with proportion to the quantity being measured or which is given the input. Or in another way, we can define sensors as it is an input device which provides an output, that is in the form of signals, with respect to the specific physical quantity, or a device that converts signals from one energy domain to electrical domain. Since signals are considered to be electrical domain, so output is in the form of electrical domain. So you can see here sensors, it may be position or height, speed, temperature, location, different types of sensors. Through computers, processing will be done. After that, it will be given in the output, maybe for the engine or flaps or motor or wing. Typical example of the sensor is being taken here. So ultimately, to define the sensor, it is an element that produces signal proportional to the input being measured. Next, few more sensors you can see here. Color, to sense the color sensor, gas sensor, so water flow sensor, rain sensor, infrared sensor, touch sensor. So to sense the particular activity, particular type of sensors are being used. The right extreme corner you can see proximity sensor, which we will discuss today. Examples of sensors. For example, again your dial indicator is also a sensor, because the indicating spindle acts as a sensor or detector for the displacement. Bourdon tube can also be considered as the sensor. First, in two ways it is considered as sensor. First, to sense the pressure. Second, to give the output in the form of displacement. Here, tube acts as a sensor or detector transducer. Compressive load cell, which you have used in the metrology lab. The platform detects the force and gives an output in the form of deflection. This deflection may be further converted into electrical output by strain gauges called secondary transducer. Smart sensor, another example, where multiple sensors are given to one will act as input to one more sensor. Again, it processes and gives the output. So smart sensors are nothing but they are signal conditioning elements with multiple sensors being given as input. So small sensor applications, communications, computations, multi-sensing. So at a same time you have to sense multiple things. Self calibration, one more specialty of the smart sensor is self calibration. That is, they will automatically calibrate themselves. The parts of the sensors are sensing elements. It may be transistor, capacitor, or photodiode, etc. Then conduction of signals and processing. And third part is sensor interface. So one interface is there between the signals and the input, which is in the form of transistor, capacitor, or photodiode. So input may be transistor, capacitor, or photodiode. In between the input and output, sensor interface will be there. Now let us classify the sensors. Again, like transducers, sensors can be classified in many ways. For example, first 5 type. Primary input quantity. So what type of input you are going to give, that type of sensor we can say. If you give input as temperature, it may be temperature transducer, like that. Second, transduction using physical and chemical effects. If you are using any other physical means or chemical things in the sensing activity, they are considered as transduction principle based sensors. Material and technology. So if you classify them according to the material being used for the sensors, so on that basis it may be different material type of sensor, or based on what technology you are going to use, based on that it is classified. Property, what type of property the sensor is having, based on that also you can classify. Then application based sensor you can classify. Then again, like transducers, they can be active sensors or passive sensors. Active sensors are those which require an external excitation signal or power signal. From externally, you have to excite it. They are called active sensors. For example, LiDAR, light detection and ranging, or photoconductive cell. So externally, you are supplying the energy. Passive sensor, they do not require any external power signal and directly generate output response. For example, radiometers, film photography, like that. So they will automatically generate their own power signal or energy. So based on the means of detection also we can classify the sensors as electric signal, biological sensors, chemical sensors, radioactive sensors, like that. And common classification is based on the input given or the function they do, like temperature sensors which detect the temperature, or proximity sensor which detect the nearby object, accelerometer, IR, that is infrared sensors, pressure sensors, light sensors, ultrasonic sensor, smoke or gas or alcohol sensor, touch sensor, color sensor, humidity sensor, tilt sensor, flow and level sensor. So based on the input given or the measurement input being measured or the function they do, they can be classified. Based on conversion phenomena also we can classify the sensors, that is the input to output conversion. For example, photoelectric, thermoelectric, that is from photo, that is from light to electric, thermoelectric, that is from thermal or heat to electric. Heat energy is converted into electric energy, and light energy is converted into electric energy. Or electrochemical, electromagnetic, thermo-optic. So two or more than two combinations can also be inputs or being used in the conversion process. Again, analog sensors, they produce analog output. Digital sensors, they work with discrete or digital data. Now let us see various type of sensors based on the working or the uh, working principle. So few examples are kept for your syllabus, like light sensors and proximity sensors. Let's study the principle and working of light sensors, which are passive because they produce their own light. Light sensors are photoelectric devices or photosensors that convert light energy, whether visible or infrared light, into an electrical signal. The sensors are semiconductor devices, and this operation is based on the change in the resistance and current flow in the circuit when the light falls on them. There are three types of light sensors. Basically, they may be photodiode, phototransistor, and photoresistors. Photodiodes given here. Here, the working principle of photodiode is the junction of photodiode is given here with the reverse bias at the top. Here, the major working principle is the photons strike the junction surface. The photons impart their energy in the form of light to the junction, due to which electrons from valence band get energy and jump into the conduction band and contribute to current. In this way, photodiode converts light energy into electrical energy. Applications of photodiodes are they are used for detection of both visible as well as invisible light rays. For example, other examples are smoke detectors, compact disc players and televisions, remote controls in VCRs, clock radios, street light. It is also used for digital and logic circuits which require fast switching and high speed operation. Photodiodes are considered as one of the significant optoelectronic devices which is extensively used in the optical fiber communication system. Continue with the photodiodes. They are semiconductor junction, as I said earlier. When light falls on the junction, extra hole electron pairs are produced. That is, valence electrons are produced, and there is an increase in the reverse current and diode resistance drops. So, little bit of physics you have to go back here to understand the phenomena. The reverse current is very nearly proportional to the intensity of the light. So, the current is produced according to the intensity of the light or incident photons. So, second type of light sensors are phototransistors. So, phototransistors, these resemble a normal transistor except the fact that the base terminal is not present in case of phototransistor. Phototransistors convert the incident light into photocurrent. Instead of providing the base current for triggering the transistor, the light rays are used to illuminate the base region. The symbol and circuit of the phototransistor is given here. So, one side base, other side emitter. Phototransistors are connected in a multi-transistor configuration called Darlington pair. So, this typical type of multi-transistor configuration is called Darlington arrangement with a conventional transistor for higher current gain. So, one more applications of phototransistors may be in counting systems, encoder sensing and object detection, printers and optical control remotes, light detector, and level indication and relays. So, third one is photoresistor. So, the name photoresistor, it is a combination of words photon and resistor. A photoresistor is a type of resistor whose resistance decreases when the intensity of light increases. In other words, the flow of electric current through the photoresistor increases when the intensity of light increases. Photoresistors are sometimes referred as LDRs, that is light dependent resistors. Semiconductor photoresistor, photoconductor, or photocell. So photoresistors can also be called as LDR or semiconductor photoresistor or photoconductor or photocell. Photoresistor changes its resistance only when it is exposed to light. So you can see the figure here. So let's see the working of a photoresistor. So when the light falls on the photoresistor, some of the valence electrons absorb energy from the light and breaks the bonding in the atoms. The valence electrons which break the bonding with the atoms are called free electrons. So this leads to a large number of valence electrons jumping into the conduction band, then ready to move with an application of any external force like electric field. Applications of photoresistors, they are used in street lights to control when the light should turn and when the light should turn on and when the light should turn off. So automatic turning on and turning off of the street lights. When the surrounding light falls on the photoresistor, it causes the street light to turn off. When there is no light, the photoresistor causes the street light to turn on. This reduces the wastage of electricity. They are also used in various devices such as alarm devices, solar street lamps, night lights, and clock radios. So again, these are the applications as I discussed: automatic street lights, light meters, camera, light sensors, clock radios. So one more type of sensors we will discuss: proximity switches or proximity sensors. A proximity sensor is a sensor able to detect the presence of nearby objects without any physical contact. The micro switch is a small electrical switch which requires physical contact and a small operating force to close the contacts. For example, a conveyor belt. So, principle of working of proximity switches you can see here. Switch contacts. It may be lever operated or roller operated or cam operated switches. So, proximity sensors operate with the reflections. Coming to the principle of working of proximity switch, it consists of two magnetic switch contacts sealed in a glass tube. When a magnet is brought close to the switch, the magnetic reeds are attracted to each other and close the switch contact. It is a non-contact proximity switch. Reed switch is a non-contact proximity switch. So let's not go into the deep. Just the working principle and the applications. Applications: checking the closure of doors, used with tachometers, and vibration measurements of rotating shafts, and seat brake sensing in paper machine, roller coasters, conveyor systems, beverage and food industries, touch screens. Again, in proximity switches also there are different types like inductive proximity, capacitive proximity, photoelectric proximity, ultrasonic proximity. So proximity means coming to the near or near detecting the nearby objects, but based on the type of working, it may be inductive, capacitive, or photoelectric, or ultrasonic, like that. So today we discussed sensors, definition of sensor, classification of sensors, and various types of sensors like light sensor, Then photo in light sensors we discussed photodiode, phototransistor and photoresistor, three types. Then we discussed proximity sensors. So this completes today's session. Any queries, let me know. Thank you.